Good morning, dear friends. Last class, I have told about concept and definitions of continuity. At the same time, I have finished all types of problems from the exercise 5.1, that is the verifications of continuity functions by using the formulas like LHL is equal to RHL is equal to function value. At the same time, I have finished the verification of continuity problems with the help of the formula limit value is equal to function value. At the same time, we have found that some unknown values whenever the given functions are continuous at a time how we are going to finding the value of k. About all these problems also we discussed in the previous classes. Now today we are going to discussing about a new lesson, application of derivatives. Application of derivative. Application of derivatives. Derivatives. Thanks. In application derivatives, we are saying first lesson is rate measure. First lesson is a rate measure. Here, little bit, we are going to applying some physics application here. And what is meant by acceleration, and what is meant by velocity, and what is meant by displacement. Like that, we will see some different types of definitions, and we are going to collecting those from physics only. Maybe you have learned about all these in first piece. Maybe what is meant by velocity, and what is meant by acceleration, and what is meant by displacement here. Up to that, in first order differentiation and second order differentiation, we have taken differentiation with respect to x there. But here we are going to taking differentiation with respect to time. Time means that velocity is moving some 10 centimeters per second. The velocity is moving, that velocity with a body is moving with velocity some 80 centimeters per 80 meters per time, 80 meters per hour. Like that, you may see wherever, if you can see like those problems, they are all belonging to application of derivatives only, and especially they are all belonging to rate measure. But this acceleration means what is meant by acceleration here, and what is meant by velocity, and what is meant by displacement here. Velocity means the rate of change of displacement is called velocity. Acceleration, the rate of change of velocity is called acceleration. Like that, we will see some different types of definitions in the rate measure lesson. But we don't want the definitions of all these to solve this chapter here. Just we must and should know about these two enough. Wherever, if you can see that centimeter per second, meter per second, or centimeter per minute, meter per minute, or centimeter per hour, meter per hour, in those types of situations, directly you must take a differentiation with respect to t only. For example, the radius of circle is changing 3 centimeters per second. 3 centimeters per second. Like that, if you can mention means you can take dr by dt is equal to 3 centimeters per second, where r is the radius of the circle. Otherwise, the volume of a cube is changing 8 centimeter cube per second. Like that, if they can mention. At a time, we must and should take dv by dt is equal to 8 centimeter cube per second. Otherwise, a circle, the area of circle is changing. The area of circle is changing at the rate of 8 centimeter square per 8 centimeter square per minute. At a time, we can take dA by dt is equal to 8 centimeters per second. That is the rate of change of area, the rate of change of volume, or the volume is increasing, volume is decreasing, area is increasing, area is decreasing. If you can see like all those words, directly you must and should take a differentiation with respect to T only here about those only. I am telling today. In problems, they are going to mentioning each and everything, but they are going to giving a increasing or decreasing rate of change of or changing like all these words allotted to which term we must and should collect that word here. That is area or volume or length like that. They are going to allotting any one of all these three words. First one is displacement, velocity. Definitions of velocity here. The rate of change of displacements. The rate of change of displacements. The rate of change of displacement is called displacement is called velocity. Is called velocity. And it is denoted by 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 ds by dt. V is equal to ds by rate of change of displacement. The rate of change of displacement is called velocity. Acceleration. Acceleration. The rate of change of velocity is called the rate of change of velocity. The rate of change of velocity. The rate of change of velocity is called the rate of change of velocity is called acceleration. And it is denoted by and it is denoted by and it is denoted by dv by dt. dv by dt. Like that we will see some rate of change of velocity, rate of change of acceleration, because same application we are going to apply to some words like area, volume, lengths. I'll tell you about those also, how they are changing. For example, note for this. Note 1. The area changing. The area is changing or overall. The rate of change of area. The rate of change of area or overall. The area is increasing. The area is increasing or decreasing or decreasing. To all these terms, when you are seeing like all these statements, if you can see like all these statements in the given problem, directly you must and should consider dA by dt. dA by dt here. For increasing means you take a positive, but decreasing means negative, like that. If you can see like all these words, the area is changing, the rate of change of area, the area is increasing or decreasing. Like all these words you are saying is statements means directly you must and should write with dA by dt. Or otherwise, the volume is changing, the rate of change of volume, the volume is increasing or decreasing. In that case, you must take a dV by dt. The length, the radius of circle is changing, the rate of change of radius of circle, the radius of circle is increasing or decreasing. At the time you can take dr by dt, or if you can mention the x is radius, you must and should take dx by dt. Like those points we must and should apply to solve the problems of rate measure. Even if you can write for that also. Second, the volume is changing. The volume is changing. The volume is changing. Or we can write the rate of change of volume. The rate of change of volume. The rate of change of volume. Or we can take the volume is increasing or decreasing. The volume is increasing or decreasing. The volume is increasing or decreasing. Increasing or decreasing. If we can say like all these statements, then definitely we can consider dV by dt. With respect to time only we are going to taking differentiation with respect to with time. With respect to time only in case of rate measure, because the one should mention per second, per minute, per hour. If you can see in like all these methods, directly you must and should take a differentiation with respect to time. Like all those problems today we will solve from exercise maybe 6.1. We are going to collecting like all these problems from the exercise 6.1. Now let us we are going to solving those problems. Exercise 6.1. The radius of circle, third question. The radius of circle, the radius of circle, the radius of circle is increasing uniformly. Is increasing. Is increasing uniformly. Is increasing uniformly 3 centimeter per second. 3 centimeter per second. Find the rate of change of area. Find the rate of change of area. Change of area. Find the rate of change of area of the circle. Area of the circle. Area of the circle. Area of the circle when the radius is when the radius is 10 centimeters. They gave a rate of change of radius. Rate of change of radius they are giving here. But we have to find out the rate of change of area when radius is 10 centimeters. How much we are getting a rate of change of area here. Now let us we are going to giving solution to this question. Solutions. Let's x be the, let's monitor x be the radius of the circle. X be the radius of the circle here. Radius of the circle. And let's A, capital A be the area of the circle. Area of the circle. Given that, what they are giving you, we should write here. Given that dx by dt they give, because the mentioned for 3 centimeter per second is the radius of circle is increasing uniformly. That means we should take dx by dt. Dx by dt nothing but the rate of change of radius. The rate of change of radius can be written as here dx by dt is equal to 3 centimeter per second. And they are giving dA by dt is what? How much you are getting the dA by dt is question mark when or x is equal to 10 centimeters. What is the area of circle formula here? This is the given in the question. Here they are asking question on rate of change of area of the circle. When they will ask rate of change of area on circle means we have to apply area of circle formula. What is the area of circle formula here? A is equal to 5x square. Consider A is equal to here. Consider A is equal to here 5x square. Now differentiation with respect to t. Differentiation with respect to t. How we are going to take differentiation with respect to t? How we are going to considering this problem is belonging to rate measure means, see if you can observe the question, the rate of change of area is 3 centimeter per second. Already I have told also centimeter per second, centimeter per minute, centimeter per hour, meter per hour, kilometer per hour, kilometer per second, kilometer per minute. Like those methods, like those words you are seeing in that problem means directly you must and should consider those types of problems are belonging rate measure only. At the same time, little bit you are going to applying here formulas of mensuration, because this lesson is depending upon formulation of mensurations also here. Area of circle, area of rectangle, area of square, cone, like those like that you must and should remember the formulas of mensuration also here. Now in this question they are giving the question on circle now, and at the same time you have to apply area of circle here. Area of circle A is equal to 5x square. Differentiation with respect to t, then we can write here dA by dt is equal to, and differentiation of pi x square is 2 pi x. At the same time, once again, x differentiation with respect to is dx by dt here. Now, we are asking here the rate of change of area when radius is 10 centimeters. That is dA by dt. dA by dt when x is equal to 10 centimeters is equal to 2 pi into instead of x we must and should take 10. Already dx by dt in question only they gave, that is 3. On taking product to all these things, we can write it is a 10 and it is a 20, 60 centimeters square per second, because the area is always measured in square units. That's what, after getting that answer on area, we must have to mention with units, that is centimeter square per second. That's what here. Finally, we got the answer is dA by dt is equal to dA by dt is equal to 60 centimeter square per second. 65 centimeter square per second. Like that, we are going to giving the solution. It is one of the questions from exercise 6.1. Now let us, we are going to solving other questions from that exercise 6.1. Next question is, find the area of, find the rate of, find the rate of, find the rate of change of area, rate of change of area, area of a circle, of a circle, of a circle with respect to, with respect to, with respect to its radius, its radius, with respect to its radius r, small letter r, when, first question they are asking here, when r is equal to 3 centimeters. Second question they are asking here, when r is equal to here 4 centimeters. Directly they mentioned here, because they did not give centimeter per second, centimeter per minute. Directly they asked in the question only, we have to find the rate of change of area with respect to radius. With respect to radius per centimeter square per centimeter, it becomes finally. First question, let us now, we are going to give you solution for first question. Solution for this question is, first question, r is equal to 3 centimeters. That is the, where r is the, where small letter r is the radius of the circle, is the radius of the circle, radius of the circle here. Area they are asking, consider what is the area of circle formula, pi r x square. Pi x square means instead of x we considered x, or that's what we can take, area of circle is pi r square. Considered a is equal to here, a is equal to pi r square. Now differentiation with respect to r you must take here, not with respect to x, because they are asking rate of change of area of circle with respect to its radius. That's what here also, differentiation with respect to r, that is dA by dr is equal to, dA by dr is equal to 2 pi r. and d by dr of r is 1. Now da by dr when r is equal to 3, then its answer is 2 pi into 3, that is equal to, we can write 6 pi centimeter square per centimeter. With respect to r, they are asking means centimeter square per centimeter, because the mentioned measurement of r is centimeter, and generally we are going to giving unit for area is centimeter square, that's square units. They give centimeter now, according to square units we can write here centimeter square per centimeter. It is the answer for first question. Next, second question is r is equal to 4 centimeters they give. Now let us we are going to giving answer for second question. Second question is r is equal to 4 centimeters. Solution for second question. R is equal to, second question is r is equal to 4 centimeters, where small letter r is the radius of the circle. Radius of the circle. Now consider a is equal to formula pi r square here. Now differentiation with respect to r here, that is da by dr is equal to 2 pi r. At the same time, da by dr when r is equal to 4 centimeters, that's equal to 2 pi into 4, is equal to, we can write 8 pi centimeter square per centimeter. It is the measurement for area, centimeter square per centimeter. Why I am writing centimeter square per centimeter means they are asking the rate of change of area with respect to its radius. With respect to its radius means they gave measurement for radius is centimeter. That's what I have mentioned here, centimeter square per centimeter. It is the answer for second question. Now let us we are going to solving another questions. Next question. An edge of variable cube. An edge of a variable cube. An edge of a variable cube is increasing. Is increasing at the rate of 3 centimeter per second. 3 centimeter per second. How fast is the how fast is the how fast is the how fast is the volume of the cube? How fast is the volume of the cube? Volume of the cube, volume of the cube increasing is increasing when the edge is when the edge is when the edge is 3 centimeters long. They gave the rate of change of side of variable cube. Cube is there. In case of cube, all sides should be equal. That is, the length is equal to breadth is equal to height. The volume is length into breadth into height. That is, volume is equal to x into x into x. Then volume we can write x cube here. But in case of the problem, in the problem they gave the rate of change of an edge. But with the help of this, we are going to find the rate of change of volume when edge is 3 centimeters. When edge is 10 centimeters. Now, solution to this question is, let x be the let x be an edge of a variable cube. An edge of variable cube here. Given that, and let V be the, should mention about V also, let V be the volume of the cube. Let V be the volume of the cube. Volume of the cube. Given that, what they are giving, we should write them first. Given that dx by dt is equal to 3 centimeter per second. But they are asking, what about dv by dt? They are asking here. dv by dt is how much? When x is equal to 10 centimeters. When x is equal to 10 centimeters. About it they are asking here. Consider v is equal to here. Consider v is equal to x cube, length into breadth into height, x cube. Now we are going to taking differentiation with respect to t here. Differentiation with respect to t here. That is, dv by dt is equal to x cube differentiation is 3x square. And next differentiation is dx by dt. Now, when x is equal to 10 centimeters, and which value will get here, about that we will discuss here. dv by dt, when x is equal to 10 is equal to 3 into 10 square. Already they gave for dx by dt is 3 here. We should write 3 here. Is equal to, we can write 3 into 100 into 3. So this is 9 into 100. 900 centimeter cube per seconds. It is the dV by dt. The dV by dt nothing but the rate of change of volume. The rate of change of volume for the cube we got is 900 centimeter cube per second. Like that, we are doing this questions. These are all the problems. They are belonging to rate measure. Rate measure means centimeter per second, meter per second, and kilometer per hour. If you can see like all these words directly, we must and should take a differentiation with respect to t only. Like that, today I have finished some problems on circle and cube also. And next class onwards, we will solve different types of problems on circle, rectangle, square. Like that, we will see different types of problems on rate measure. Thank you very much.